Okay, this is point 6.1. We're starting factoring, and I will start by telling you that factoring is, in my opinion, the most important thing that you learn in this class. This concept will be used for every other math class that you take going up, whether you go strictly to trigonometry or pre-calculus or Calc 1 or Calc 2. All of those classes, you will need to know how to factor. That is how important it is. So if you need to do these notes 2 or 3 times, if you need extra practice, I will probably put some extra practice worksheets online. You need to be able to factor, and you need to be able to factor fairly quickly. When you go on to the next class, 113, we do a quick half a day review of factoring, and then we're going to be using it in other concepts. So please make sure that you're able to factor. So factoring comes in all different types. First of all, I want you to understand that what factoring is unmultiplying. And I will explain that as we go through all of the different types. But that is what you are doing. You are taking something that's been multiplied together, like we did in Chapter 5. We FOILed, we distributed, we did all of that multiplying together. So what factoring is we're taking that thing that we multiplied together and we're splitting it up, or we're breaking it up into the factors that make that polynomial up. So the first thing we're going to talk about is just a quick review of greatest common factor. So I want you to remember, what is the greatest common factor? The greatest common factor is the largest number that divides into, in this case, both 15 and 30. What's the largest number that divides into both 15 and 30? Well, that number is 15, because 15 divides into 15 evenly and 15 divides into 30 evenly. If we look at B, what is the largest number that divides into all 3 of these numbers? Well, you might think 9, but no, 9 does not divide evenly into 12. It does divide evenly into 36, so it's going to be less. The answer is 3. 3 is the largest number that divides into both 9, divides into 12, and divides into 36. So this first section, 6.1, is actually going to be 2 different types of factoring. The first one is finding the greatest common factor. So if you need to go through a process to find the greatest common factor, this is the process that you've learned in other classes. I would certainly hope, quite honestly, that you wouldn't need to go through this process, but if you do, here it is. And I'm going to show you with 2a this process as we find the greatest common factor. So it says, write each term of the expression as a product of prime factors in exponential form. Identify the common prime factors and or variables that have the smallest power, and then you multiply it back out. So here's what that means. So if we look at 28a cubed, so what they mean by identify the prime factors is they mean to make your factor tree. So let's quick remember how to make a factor tree. So what multiplies together to get 28? Well, 4 times 7. And then you know the 4 can break down into 2 and 2. The 7 doesn't break down. So if I were to write this first term, 28a cubed, as a product of its prime factors, it would be 2 squared times 7 times a cubed. Okay, so there's the first one. Now we have to do the second one. Well, let's prime factor 21. Well, we know that that's 3 times 7. And there's really nothing else we can do there. Those are both prime. So it would be 3 times 7 times a to the 4th times b. So here are each one of the terms written out as a product of prime factors. Now, what does B say? It says, identify the common prime factors. Well, we're going to kind of build our GCF here. So we want to identify the common ones. Well, you can see that they have a 7 in common and they don't have any other numbers in common. So that would be 7. What else do they have in common? Well, they have an A in common. They don't have a B, but they have an A. And then it says that have the smallest power. So since you have an A in common, we're going to take the GCF is the A cubed, the one that has the smallest power. So the greatest common factor for 28 A cubed and 21 A to the 4th B is 7A cubed. So the numbers, I hope you're going to be able to do that kind of without having to show all of that work. But the variables, it's going to be important for you to remember that if they have a variable in common, you're always going to, for the greatest common factor, take the smallest exponent that appears on that variable. Well, let's look at this. Now notice there are no numbers, so we don't have to worry about that. But what do these two terms have in common? Well, they have a B in common and they have a C in common. So now we go back and we take the smallest variable. Well, on a B, what's the smallest variable exponent? So this has a 3 and this has a 5. So that means we take the B cubed. And I hope that makes sense to you because we're trying to find out what they have in common. They have a B cubed in common because hidden inside this B to the 5th is a B cubed. They wouldn't have a B to the 5th in common because there is no B to the 5th hidden inside this B cubed. And as for C, our exponents are 1 and 4, so we just, for our greatest common factor, it's going to be C to the 1st power. And there's the greatest common factor. Okay, so now let's apply that to the actual factoring. So what you need to know is when you are factoring out a greatest common factor, what you're really doing is unmultiplying or undistributing. So you are undistributing what has been distributed or multiplied through. So if we look at these two terms, what's the greatest common factor? What's the biggest thing that divides into both 16 and 20? Well, it's 4. Do they have any variables in common? No. This one has a y, this one does not. So now think of what distribution looks like. Remember, there's something left in parentheses, right? So how do you figure out what's left inside these parentheses? Well, we're going to divide. 16 divided by 4, there's going to be a 4y plus 20 divided by 4 is 5. And we have, at this point, factored out the greatest common factor. If I were to distribute that 4 back through, do you see where I would get my original binomial? So we're undistributing. Let's look at B. What's the greatest common factor here? Well, it's 3. They don't have any of the variables, all 3 of them in common, so we can't factor that out. So what's going to be left? Well, 9 divides by 3 times, so 3a plus 6 divides by 3, 2b minus, and 12 divides by 3, 4. Why am I dividing? Because I'm trying to figure out what's left. So now, since dividing is the opposite of multiplying, and I'm going to be multiplying these to check it. C is going to be a little more complicated, so just take the numbers separate from the variables. So if I look at just 27 and 36, what's the biggest number that they have in common that divides into both of them? I'm thinking that's going to be a 9. Then you can see that they have an A in common and a B in common, but make sure you take the smallest exponent, so that's going to be e to the 1st and b to the 2nd. There's my greatest common factor. Okay, now that we've taken that out, we've unmultiplied it or undistributed, let's see what's left. Well, 27 divided by 9 is 3. There's no a's left, but there's going to be a b because b cubed divided by b squared is b. Minus 36 divided by 9 is 4. A squared divided by a is a. And b squared divided by b squared, those cancel out. And again, you should never miss a factoring problem because you can always distribute it back in to make sure that you get your original polynomial. Okay, let's look at D. Well, what's in the number-wise, what's the largest number that divides into 12, 4, and 6? Well, that's going to be 2. You can see that they all have an x in common and a y in common. So what's the smallest exponent that appears on an x? It looks like it's a 2. And how about the smallest exponent that appears on the y? That also looks like a 2. So that's our greatest common factor. We're going to factor out. So let's figure out what's left here. So 12 divided by 2 is 6, and we took out 2 of the 5, so that's going to be x cubed y minus 4 divided by 2 is 2. There's going to be an x left and a y squared, and then plus 6 divided by 2 is 3, but notice how the variables cancel out, and we are done. For E, the point of E is sometimes it's advantageous to take out or have your greatest common factor be negative. And here's a situation where that's true. Notice how both of the terms are negative. It would look a lot nicer if they were both positive. So to do that, we're going to factor out a negative. What's the largest number that divides into 3 and 6? So we're going to factor out a negative 3. You can see that they have an R and a T in common. R to the first is the smallest exponent, and T to the first is the smallest exponent. So let's go ahead and let's divide and see what we have left inside the parentheses. Well, notice a negative 3 divided by negative 3 is 1, so we don't even have to write that. R squared divided by R is R. Now notice negative 6 divided by negative 3 is positive 2. And the r's cancel, and you're simply left with a t. And there you go. We're going to stop this video, and we're going to go on to part 2.